Hello, everyone. My name is Chris Ayers. I work on the Fast Track for Azure team here at Microsoft, helping customers deploy onto Azure. And today we're going to be talking about leveraging API management for OpenAI applications. And I'm joined by Elena. If you want to introduce yourself.
And Елена Yaroslavskaya. I'm customer success cloud solution architect specializing on bringing Gen AI solutions to customers.
Excellent. So I'm just so happy everyone's able to join us and we get to talk about this cool stuff. So today we're going to start with just a little bit of overview of some terms around the OpenAI service, just a high-level overview of some of the issues that you're going to face potentially with tokens and rate limiting. Then we're going to talk about APIM and some of the capabilities of the API management service that we're going to leverage in our solutions with some demos and some blog posts that might help you implement those solutions to scale your API management. And then Elena is going to dive deep into security and how we can lock down those solutions with identity and private networking and stuff. So I think there's a lot of cool things that we're going to get to talk about today. Well, let's get started. So OpenAI terms, just as we go through this, as we're going to start looking at some of the things, understanding tokens. And tokens are not individual words or letters. They're just kind of units of text that are processed by OpenAI and Azure OpenAI and the models. And these are a measure of kind of the input and output of the system. And that's how you have quota and how you have billing. And so quota is really just that maximum amount of like requests or tokens you can use at a given time. Like if you have so many tokens per minute or so many requests per minute. And we'll talk about that in a little bit more detail. Another term that's very important to understand is the model. So we have a lot of different models. GPT-3 was a huge ground-changing model. We've got GPT-4. There's GPT-4 with vision. And we also have some different ones that are used for like text embeddings. And text embeddings are used for searching and indexing your own data. So these are all very important things to keep in mind because we're gonna touch on them a little bit deeper in a little bit. API keys. So just like we secure our APIs, OpenAI secures its APIs through either something like a managed identity or a specific API key that you have to attach to your requests. And Elena, I think you're gonna go into some of that in depth, right?
Oh yeah, IPI keys are my favorite security measure.
Oh, I'm sure they are. Just embedded in an application that you can kind of look at and go, huh, that'd be fun. Rate limiting. So when we are using the applications, we start scaling, and we're starting to use more and more words, more tokens. We have more users and additional requests. We'll sometimes get rate limited, and so we might start seeing some weird HTTP requests with a 429. So 429 is usually the status code HTTP uses for rate limiting to tell you need to slow down or wait another minute to try your request. And finally, with OpenAI and the Azure OpenAI service, there's a couple of different deployment models for billing. There's just the pay-as-you-go, where you can use as much as you want, but it's kind of a shared service. So you might have to be trying to use that service at the same time other people are trying to use that service, and that can induce latencies that you might not be expecting. And then the other option is PTUs, or provision throughput units, where you actually are paying for a certain amount of capability and quantity, and that way you can kind of have that guaranteed capacity that you need for your enterprise applications. So now, just kind of digging a little deeper into tokens, this is an example of how different texts, so those prompts that you asked the GPT model, the histories, the requests you get back are broken into tokens. And a token is usually about 4 characters. So in a given 75-word paragraph, it might be about 100 tokens. And highlighted in different colors are how the tokens in this example are split up. And that's why we use different services to keep track of tokens, and we try to optimize these at times. Like I said, quotas. Quotas are more of a touchy subject with a lot of customers because you can only get so much on the pay-go, and that's why we talk about the PTU model. But quotas are going to be not only specific to your subscription, but region. So in a given region, if you do like a GPT-3 model, it doesn't matter if you have 5 or 6 deployments of GPT-3 in East US2, for instance, they're all going to share that same quota. So you're not going to be able to get additional requests just by spinning up another copy of GPT-3 in East 2. It's tied to your subscription in your region. So in a lot of cases, when you want to start growing your application and taking more tokens, you need to look at using other models or looking at other regions. And so now we start getting into that place where we need to start thinking about load balancing or having requests routed amongst different instances. Like I said, we grow our requests, we grow the complexity of the task we're doing, more data, more messages, and so we're going to start hitting those token limits. A lot of these might be measured in 10,000 tokens per minute or tokens per hour. And so if you're using 5,000 in the first 10 or 20 seconds, you might start to get throttled. So there is a conversion metric about like requests per minute that you get, but also, if you have 6,000 tokens per minute, that's probably about 1,000 every 10 seconds, but you can get throttled if you use 20,000 or 30,000 in the first 10 seconds. So this is where the problem arises for so many of our enterprise customers. Elena, I know you and I chatted about this before. Like, this is one of the biggest complaints customers have. Like, they start getting rate limited as they start scaling up. They're like, how do I solve this problem?
Favorite 429 error. Everybody complains about it. Yes.
Everybody. So API management comes to the rescue. We do have some other solutions, but I'm a huge fan of API management for this. Not only do we have like organizations that provide APIs for their customers, and they use like the developer portal, and they can do different authentication mechanisms. It does rewriting, and we have policies where we can kind of integrate JSON or XML or whatever behind the scenes and adjust paths and all sorts of stuff. And so by leveraging APIM, we kind of abstract away the APIs behind it and allow us good monitoring and security on top of our current APIs. And so we have a couple of solutions different teams have built. So, and they leverage these policies. This lets us transform those APIs. This lets us kind of not only provide our own rate limits. Let's say we put out a client and we're getting spammed by 20,000 requests every second just trying to hit the chat models. Well, we can rate limit them to more reasonable levels. We can authenticate and authorize them. For some of our APIs, we might cache. And so leveraging these capabilities, we've implemented a couple of solutions to support those API backends. And this is where for each backend will be a different OpenAI deployment or instance that we can route traffic to. There's a couple of new features coming as well that I'm going to talk about that have recently rolled out or in preview in APIM that really enhance these capabilities. One of the first solutions that actually one of my coworkers wrote, Andre Dews, he wrote a solution using policies to do prioritized backends. So in a given region, let's say in the East region, I want to have a PTU and a pay-as-you-go model. I can leverage those as long as I want until I hit that 429, and then I might route my traffic to something on the West Coast that's still a valid model and lets me expand my capabilities, but it's not the desired one. And it will pick up that 429 message that comes back from the OpenAI service and tells you retry after 12 seconds, retry after a minute, and it will automatically kind of mark those as not usable for that 12-second window. And then as soon as it's back up, it'll switch back to that priority one model. I'm going to show this in a second. Another pattern, and this is where we're coming into some of the preview services, is they've expanded some of the capabilities of the policies to allow things like a circuit breaker pattern, where you can now define a backend pool of 3 or 4 different API services and say, when you see a 429, that's the thing that is going to trigger the circuit breaker. That's the thing that's going to stop you sending traffic to it. And then you can put them all in there. This doesn't give you that same level of prioritization, but it will just kind of load balance across them with that circuit breaker pattern. So it's a really good capability, and I'll be able to share that link hopefully later. So let's just quickly look at what this looks like. I've got on my screen some code here, and this is just a very basic Python sample where I'm leveraging one of those solutions we talked about. I'm going to use APIM, API Management, to sit in front of all of my OpenAI instances, and I can just call it like I normally would, where I'm going to be using API Management, I'm going to be using the subscription keys and call OpenAI just like I normally would. And I can, call my APIM and I can get the response back from OpenAI just like I normally would. This is part of that Azure OpenAI load balance sample. Let me actually bring up the Azure portal. This is where it's deployed 3 different instances and 3 different regions across the United States. And if I look at my API management, I've defined each of those as a backend. So these are 3 different backends that are going to be leveraged by the policy. And I've got an API here for OpenAI, and I can test this. I'm going to use a deployment of chat, and let me quickly get my API version. I always forget it, so I'm cheating a little bit. And we can just send this little test message, and we can see 200. We're getting a response back from East 2, and I can send it again, and now I'm getting North Central. So just by leveraging some of the policies, I can see my rate limiting, my request limits, my token limits, and I can have it automatically balanced between multiple instances that I've configured at a really, really low level. Now, this solution is out in Azure Samples as OpenAI APIM load balancer, and we've got documentation on how to manually deploy it with AZD. So this is a cool way to get started and play with this type of solution and scale horizontally across multiple instances. The same team also worked on providing a container app load balancer using YARP and .NET. It's another really cool solution where you can actually click a button to deploy it, fill in a couple of endpoints, and have it load balance across that. So we've got some really cool capabilities, and I know we already touched on that circuit breaker, where we can leverage the circuit breaker capability to do rate limiting across the 429s. So APIM is so flexible. The API management lets us not only not share all of our secrets with our customers, because I don't know what the access keys are for OpenAI in this deployment. This is a managed instance, so managed identity. My API management is allowed to talk to my OpenAI, and they talk without having a secret or a key because they're authorized to talk in the cloud. They have the rights and roles to talk to it securely. I have to have a key or an identity or some way to talk to API management to do that effectively. And I'm going to talk about all that security and hand it over to Elena, but some of these things are all found in a AI in the box solution. This is a solution that a lot of fast track members and CSAs and other engineers inside Microsoft have contributed to, where we have solutions around MLOps and Edge and these APIM solutions, and we have some guidance around responsible AI and some guidance around security for these generative AI solutions. All of the different attack vectors that could come in while you're leveraging these large models, and APIM helps lock that down. And so I'd like to turn it back over to Elena to keep talking about that security aspect.
Thank you, Chris. So now that we've seen how to improve scalability, right, with smart load balancing, we improved scalability and quota problems. Right? Now let's take a look. How do we put it now in production? Any deployment of application to production requires security. And thank you, Chris, for highlighting this repo, as I would like to show actually show this awesome GenAI security page that team put together with all the links. It summarizes many attack vectors. It shows OWASP top 10 for large language model applications, potential risks. LLM apps are now embedded in almost every application in our work and even personal lives. And there are new challenges coming with that. And we also highlight here security strategies that help mitigate all these risk factors. So one of them is, I think, very important one, is architecture strategies. We have number of blueprints and reference architectures that actually help secure and build scalable and available environment. And you could see all these links. What is even better, my favorite, they come with bicep files that actually all the bicep scripts to provision for you all the architecture with private networks, private endpoints, all this heavy lifting is done in these baseline architectures. Aspects that we also need to kind of concentrate a lot with our enterprise customers specifically, and any customers really, is network strategies, right? Where we have to look at proper network segmentation and make sure all our interactions with OpenAI, with any other cognitive services, always goes through our internal private networks and never leaves into open internet, let's say, right? And for that, we also have a lot of in-a-box solutions. But what I wanted to show you is one of the most popular ones, one of most popular blueprint architectures that you could see here. It's coming from our architecture center. And it basically provides a very comprehensive solution for centralized logging, auditing, monitoring, and also secure authentication of incoming traffic into our LLM apps. Everything is deployed in our private network. The only single entry point, which is kind of internet facing, is on application gateway, which forwards traffic to our internal network with IPI management being cornerstone of the solution. It basically does all this smart load balancing that Chris was showing to different OpenAI instances to increase quotas, high availability, etc. But it also responsible for centralized logging. So all traffic could be logged and audited as it goes. It also is providing authentication and authorization of all the incoming tokens and identities that are trying to invoke our open AI LLM apps. And if I zoom in a little bit on the networking aspect, we see that IPI management, which is VNet integrated and internal and all these goodies, also connects to virtual networks and private endpoints of our OpenAI instances. So everything, all the traffic goes through private networks, as well as to other services that are supporting API management. You might use Key Vault, storage accounts that stores some additional information. So everything is secured, and all communication is enabled with our Azure Active Directory, or Entra ID, as we renamed it, and managed identities for any airbag control. And that's one of the next mitigation strategies that we have, is although we do tend to use API keys in our POCs, demos, we all did that, right? But in production kind of scenario, we would like to go totally keyless or passwordless, right? And offload all the identity and authentication to Microsoft Entra ID, Azure ID in the past, where everything is communicated through tokens, right? In this scenario, client application, and typically when we deal with LLM apps and GenAI, There are many frameworks that actually developers love and use, such as LangChain, semantic kernel, and so on. So this application in that case would authenticate the user, obtain token from Azure AD and ID, and pass this token for authentication to IPI management, and subsequently IPI management could invoke OpenAI. So what happens in this scenario, there are a couple of possible options where token that we obtain is token to authenticate to IPI management, and IPI management would embed managed identity of itself when communicating to OpenAIs. Right? In this case, API management is kind of main infrastructure point that validates your tokens, validates their claims, their signatures, audiences, and all that, and making decision if to accept or reject traffic, and forwards the requests. In some other cases, we've seen the need where application needs to pass token all the way throughout, where API management is kind of transparent proxy. It still validates the token, but instead of embedding managed identity, it passes it all the way to OpenAI. But it still acts as control gate for validating your tokens. So how do we do that? Let's see how we do it in code, because that's where typically is the most fun is. So let's start from bare bone HTTP communication. So first thing that we need to do is, of course, getting the token. Any application, any framework would do it behind the scenes for you. But just to see how it's typically done, we do typically have specific calls, how we obtain access token from Microsoft Entra ID. What is important here to note is your actual audience, right? Where your request is targeted for. So in this case, we target our audience to be IPI management gateway, and we get the token for it. And once we got the token, we embed it in our typical authorization header, right? And we could send request with our typical OpenAI chat completion API, as you could see here, OpenAI deployments chat with proper version, and receive a response similar to what Chris have shown you. So we get the response, and I could see which actual backend it hit in the API management. So if I iterate over them, there is good probability I'll get different ones. So here is different backends that load balanced by IPIM, but having this authorization token in the mixture. So how we secured it, what I haven't shown you, the magic source here is that inside IPIM, what we added to the typical smart load balancing policy, we added policy to validate JOT tokens, validate these authentication identity tokens that are incoming. We see here the same audience that we use to obtain the token, and we validate additional required claims, issuers, signatures, and whatnot. So it's very simple policy in IPIM to enable it. And that's all good with HTTP, but what if you have frameworks that you need to use, how to do that? So typically, as Chris was also showing you, we use typical Python OpenAI kind of constructs where we pass the keys, which preferably we shouldn't use, and we should use the token that I showed you. So how do we do that? We typically use a very standard Azure package with identity options in it, and we could obtain token. As you could see here, we obtaining token default Azure credential for the same audience that I showed you that is configured to be validated by IPIM. And now that I invoke the same call with this token, you see here Azure AD token provider, it's by itself behind the scenes does what I showed you in pure HTTP. It gets token with proper audiences from Microsoft Entra, and we now embed it in our communication, and we could, as usual, as typical, invoke all the client APIs. That's a bare bone token. Python API. In LangChain, which is extremely popular, they added the new option that you could see here. Typically, you would use OpenAI API type Azure when you invoke Azure OpenAI. Azure AD new type that allows you to pass actual tokens instead of keys, right? So that's how you actually specify to LangChain. And instead of API key, you actually get the token with proper audiences as usual, but you actually get token, not API key. Nothing is hard-coded here. And then, as usual, you could start invoking our chat completions API in a very similar manner as before. And you see here that it created the completion.
That's
So
really cool. I definitely need to go and update all my samples to use the tokens now.
Yeah, thank you, Chris. And that's exactly what I wanted to ask our listeners to do. Try to kind of remove your API keys, try to use tokens, especially if you are doing GitHub integration. We all accidentally sometimes put our API keys there, so be careful with that. Yeah, that's very simple, really. All frameworks now support it. Previously, it wasn't there, but right now, everything is supporting AD tokens, LangChain, semantic kernel, barebone OpenAI. So just do it.
Awesome. I think we had one or two more resources we wanted to share.
Yep. And let me just talk quickly about this awesome blog from Clemens, who actually pointed out that routing patterns sometimes we are using not only for load balancing, but also for cost and error handling. So some of our prompts tend to grow very big. They might become more than 32K tokens or get very lengthy. So there is ability to do it on IPIM or LangChain itself to actually fall back to bigger models, larger models, if you get big prompts and big completions. So we definitely read that, how to do that. It's very good pattern, also saving you cost because smaller models cost less. So you could use smaller typically and just fall back to bigger when you have really big text to complete. And with that, I think we could thank you, all our listeners, and ask them to secure everything and have fun with LangChain and IPIM and load balancing and increase your quota by load balancing.
Thank you so much. That very educational, got a lot of good resources. We'll try to make sure we share all that. So thank you guys for joining us.